books I'll be referring to is these are some of the important books. So Franklin F. Kuo. This is a basic book I will be referring to for most of the discussions. Okay, and you keep in mind that this theory is not that important. The theory is important to understand the things, but mostly in examination problems are asked. Okay, so you keep in mind that you have to solve large number of numericals using different techniques and all that. Then when we will proceed, you will come to know that there are some differential equations, matrix theory is involved, some graph theory is involved, and so thing. All this and then combination of everything. So the books I'll be referring to is Franklin F. Kuo, M. E. Valkenburg, D. Rai Chaudhary, S. P. Ghosh, and A. K. Chaudhary. I have another book is called Leon O. Chua and Charles A. Dessor and Ernest S. Koo. So linear and non-linear circuits and a couple of more books. So I'll be mainly referring to around 6, 7 books. But the important from where you can grasp most of the topics is Franklin F. Koo. D. Rai Chaudhary is also a good book, but somewhere because it is an Indian book, somewhere there could be some typo mistakes or printing mistakes. So you have to correct or consider them. Valkenburg is also good book. Chua is very good book where the this equivalent circuit of many of the active components and their the using them many uh, amplifier circuits, oscillator circuits, and all filter circuits, all kinds of circuits are given, and the analysis is given, and a lot of problems are given. So you will have to refer to. So, okay, so in this topic, we'll be getting around 9 to 10 lectures, and we'll be covering most of the uh, topics. Okay, so for example, you have in over here, I shown you very simple circuit. Okay, so where you have now resistance, one inductance, one capacitance is connected in series. Again, the circuits could be called as one port circuit, two port circuit, many port circuit. So, port means what? Through which you will be providing some signal to that circuit, and you will be taking out from different kind at different points. Okay, and in a circuit when there is a completion of the circuit from one end to another end, it is called a loop or a mesh. Okay, so for example, in this circuit is a very simple circuit. So you have one resistance, one inductance, one capacitance. Okay, or there could be just the connection of different resistances and some voltage source or current source is connected at some 2 points. So for from example, all these connecting points, they are usually called as nodes. ये जो पॉइंट्स डिफरेंट कंपोनेंट्स को कनेक्ट करते हैं, उनको नोड्स कहा जाता है. तो ये इनके नोड्स है 1, 2, okay, and 3. Okay, and this node again, there could be another node over here also, and then one of the nodes over here will be grounded. Okay, and that node is usually called as a datum, so with respect to which all the voltages will be measured. Okay, so that voltage at the ground or that node is usually considered as zero. So for example, in this circuit you have some maybe DC, maybe AC, or any kind of some input. Okay, is so this is just a one port network where in this port some source is connected and current flows through this. And when it is switched on for long time, how the current will vary with time. So this will be in IT, in time domain. Okay, or later we will also see whether how it behaves in the frequency domain. Okay, and that will help. For example, over here little bit more complicated circuit. Okay, where you have one source connected over here, right? And resistance, inductance, capacitance, another resistance, another inductance, another capacitance is connected in this loop. And you have also have another loop where this is also one of the branch of this, and another again some resistance, inductance, capacitance, and not only that, another source is connected in this branch. So you can have such different kind of circuits, okay. And not only that, when you go for this amplifier and all that, there are some active components like transistors, or fades, or any other kind of active components over there. And then you firstly what you have to do is you have to uh, find out equivalent circuit. So where is what, in what fashion it is connected. For example, common emitter configuration, or common collector configuration, or common base configuration. And then how the different, again the collector or emitter and that base is connected, and how the current will be flowing. So firstly the direction of that current, and also the how much is the junction, that resistance, and at what frequency it is working. So if it is working at very high frequency, then those junction capacitance will also play some role. If it is working at low frequency, may not be that significant, maybe we may ignore, and kind of thing. So all this consideration while analyzing the circuit, you have to give all such kind of considerations and analyze the circuit, okay. So for example, you have over here FET as
So,
a, yes,
so what is that node called? Ground, the grounded one.
dotum,
Totem.
dotum,
Okay, okay.
dotum, dotum, ठीक है. To here you can find out that you all already have studied all these things, okay. So this is for example fade. So this is a gate, this is a drain, this is a source, and from this you know now how to find out the equivalent circuit of this, and there are different symbols, okay. Then this acts as a current source, you know that, right? So from drain to source, it acts as a current source over here, and not only that, is a voltage controlled some current source. So they are again different. Therefore, if it is a voltage source, then just a plus minus sign is given. But if it is a current source, then direction is also given inside. So there will be, when we will continue this kind of thing. So we'll try to know different symbols also, and then at very high frequency, then you have to consider this junction capacitances and all that, that I already have explained, okay. So for example, again you have these transistors, and for that how to write down this equivalent circuit and all that, that you know, when it is biased in a particular fashion, or internal this resistances of the junction and all that, when it is working for at very high frequency, then you also have to consider junction capacitances and this or this and that thing, okay. So as I explained, so what is the network? Network is again a combination of this thing connected in a particular fashion. So symbols we use again for resistance R, and 1 by R is G, that is the conductance. Okay. For capacitance we use F, and then 1 by C we use sometimes as D, and that is called uh, elastance, and of course for inductance L, okay, and their units are resistance, you know, ohm, and also we use sometimes in, resistance is conductance, and conductance is again we use symbol Y, or this G, okay, and capacitance is measured in farad, this inductance is measured in Henry, and this all these things and combination. Sometimes we use transformers also, and active circuits like FET transistors, and so on and so forth. Okay, and a circuit will be, or network will be, the combination of this. So again, you should know the basic laws in network analysis. That is Kirchhoff's laws. Do you have any idea about Kirchhoff's law? There are two laws.
Yes, sir.
पढ़ा है ना
Sir.
आपने? तो एक
Yes,
है
sir.
Yes,
एक
sir.
है करंट
Current
लॉ।
law
The
and
current
voltage
law
law.
or loop law? The voltage law.
हाँ, लूप लॉ, जहाँ वोल्टेजेस डिफरेंट कंपोनेंट्स के अक्रॉस या कैसे ये है। तो दिस लॉ सेज दैट the voltage is the sum of all the voltages in a loop, okay, is equal to zero. So that is what it says, considering the, of course, the direction, positive and negative direction. Okay, so if in a particular loop, if you consider this particular direction over here, I have taken example. So this V1 across R1, V2 across R2, and V3 across R3, this sum, this is in a particular. So you consider positive to negative, okay, positive here also positive to, but when it comes to here, this is from negative to positive, okay. So therefore, all the signs over here will be positive, and for this sign will be negative, and sum of all these four is equal to zero. Or you can say this voltage, if you write this in this form, V1 plus V2 plus V3 is equal to Vg, means whatever the voltage you are applying or giving from a source, okay, will be distributed according to their values and all that across different kind of components. Now here it is easy to write all these things because here all the components are resistances, okay. But if there is a component like capacitance or inductance, then what happens is inductance will be charging with time, right? So therefore the total current or total voltage generated or stored inside, energy stored, will be some integration kind of thing. So the integration will come depending upon voltage and depending upon whether it is a current or voltage we are considering. Similar will be the case, okay, with inductance, depending upon again whether it is current, and so therefore derivatives and integrations will come in your this equation, okay. So if it is integral differential equation kind of thing, so one derivative is there, one integration. To eliminate that integration, we will have to again differentiate one more time. So therefore mostly in such kind of circuit where inductances, capacitances, and resistances are um there in the circuit, then second order differential equation comes as equation for that particular loop or for that particular circuit. And when there are such kind of different nodes or different loops and more complicated, more simultaneous such kind of whether first order or second order differential equations will come, and we have to solve all these differential equations using our all previous knowledge about the circuits, and find out initial conditions if they are not given. If they are given using those initial conditions, we have to solve all the differential equations. So knowledge of differential equation is very much essential for these analyzing these circuits. Okay, I will take a couple of minutes breaks because I have some So okay, so that is what we are discussing when there will be capacitances, resistances, and other active components. Okay, so we will generally usually get first order or second order differential equations, and we'll have to solve. So that is what mostly we'll be doing. So again, you know this Kirchhoff's law, this current law. Okay, so at some particular node, okay, all the currents. So that was the example that I had given was that of the voltage law. So when in a loop, okay, the voltage dropped across one. When we will be considering these nodes, okay, so the current flowing, because current at particular point cannot remain over there. So therefore, the addition of all these currents, okay, at a particular points coming from all the sources from all the direction is equal to zero. So this is a KCL, or called Kirchhoff's current law, and we will be referring this as a KCL many of the times. Okay, so here you can see here the currents again coming towards this node, okay, is usually, no, here it is something wrong here. Coming towards all these things is referred as negative, and going away is referred as negative, and coming towards is referred as positive. Is that okay? So therefore, the direction are very very important in this circuit, and you will find that while solving or while analyzing the circuits, you have to consider whenever you will be doing this node analysis, you have to consider this law. So you know all these things earlier, right? Hello.
सर ये अपने पे डिपेंड होता है ना सर, मुझे कौन सा नेगेटिव लेना है या पॉजिटिव लेना है?
कैसे डिपेंड होगा? फोर्स जो है आप समझे नहीं, जब डॉटम है, डॉटम को जीरो कर दिया आपने, एक पर्टिकुलर नोड को जीरो कर दिया, ठीक है, या गिवन है तो सर्किट में, तो वहां से शुरू करेंगे हम,
ठीक है।
या किसी और कंपोनेंट से भी शुरू करेंगे। यदि सोर्स गिवन है तो करंट तो नेगेटिव से पॉजिटिव की तरफ ही फ्लो होगा।
यस सर।
तो वहां सोर्स से आप डायरेक्शन शुरू करेंगे, जब भी करेंगे ये करके, तो आपको वो डायरेक्शन फॉलो करनी होगी। तो वो जो दूसरे कंपोनेंट में कनेक्ट करने वाला जो नोड होगा, ठीक है, तो इधर तो वो वहां से उस नोड के तरफ आएगी या नोड से बाहर जाएगी।
यस सर।
हाँ, सो देयर दिस विल बी वेरी इंपॉर्टेंट, नो? ओके, ऑलराइट। So again, then for these different components, as I explained, for resistance there is no problem. So voltage drop across this with time will be the same. So voltage drop across a resistance will be R into IT at any time t. So whatever at any time, depending upon your again signal, or depending upon your source, what the whether the current is varying with time or whether it is DC and all that. Okay, no integration or derivative will come. Okay, and we can write just the simply R into that current, or voltage divided by that R is equal to current. And similarly, this G, okay, inductance will be 1 by R, that we have seen. But when it comes to a particular capacitance, the current flowing here will be the time dependent, because it will be charging or discharging during that time, right? And therefore, IT with time, you have to always remember that current, you have to write C into dV by dt, or d by dt of that particular voltage when you are writing current. When it is a voltage, again it is charging, so it will be 1 by C into from 0 to t at that time, and we write this sometimes 0 minus. 0 minus means just before starting or switching on, or just after switching on. So we give, most of the time you will find this symbol 0 minus or 0 plus, and most of the time 0 minus is equal to 0 plus also. In exceptional cases, we'll find that this 0 minus may not be equal to 0 plus. So again, it will be the integration of it, I tau d tau. Okay, so with time again, if you put after integration, so it will be the time variable plus again for how much time, whether it is already charged, whether it is switched on for a long time, or whether you are just switching on, this vc 0 minus will also appear, and this will tell you about the initial condition. So in a circuit, when there is a resistance, there is absolutely no problem. Okay, you can write down it into r, but when it comes to capacitor, okay, this, if it is a charge for some time, this also acts as a source over here because it is already charged, and voltage will be developed across this thing. So in addition to this capacitor, you will also have to show over here some source of voltage vc0 minus. Okay, and this will be depending on whether it is switched on for a long time or whether you are just switching on and all that. So the generally these initial conditions are given, but if not given, we'll find out. We'll also discuss how to find out these initial conditions to analyze the circuit. Okay. ऑडिबल हूँ कि नहीं? कभी कभी जो है मेरा माइक को जो है अपने आप स्विच ऑफ हो जाता है या म्यूट हो जाता है. ऑडिबल हूँ मैं?
Audible.
अच्छा.
Yes, sir.
Yes,
Yes,
sir.
sir.
हाँ. Okay. And for inductance also, you know now. So all these things you must have. We are just in this class, we are just revising. And as I explained, this VC0 minus is equal to VC0 plus in most of the cases that I have already explained. And for inductance, again, this VT is equal to L into di by dt. You know that this acts as a current source, and therefore that will be in, that was in series with this thing, and this acts as a in parallel with this because two current source cannot be in series. वो तो current एक ही flow होगा उसमें, समझे ना? So therefore this will be in parallel with that inductor, another current source you will have to show as depending on whether you are just switching on the circuit or switched on that circuit previously already for a long time. And therefore Vt you have to write down as L into di by dt, and It is 1 by L 0 minus to t or 0 plus to t, V tau d tau plus this IL 0 minus. Okay, and this will give you the initial conditions. Okay, so here is summarized as this. So this is like impedance act. So V RT is equal to R into IR in resistance, that resistance current flowing. But when it comes to voltage, VLT is equal to L di t by dt, and VCT is equal to 1 by C for capacitance, 1 by C minus infinity or 0 minus, you can say, to 1 IC T dt. Okay, so all this for while analyzing, you will have to remember all these things, and you know all these again laws when they are connected in series. So equivalent will be the just the sum of all these resistances. Okay, so sometimes you need to modify or simplify your circuit. There you will use all these things. When they are parallel, we know that 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on and so forth. Okay, because the voltage drops across this will be all the current will be flowing through all these things and will get divided, and therefore this formula is there, and we know that when the resistances are connected in parallel, so this is the equivalent how to find out. So if there are n number of such resistances, so it will be 1 by R equivalent is equal to 1 by sum of each this resistance. So, and then for capacitance again, you know that when they are connected in series, okay, the parallel law applies over there. So for capacitance, you will have to remember. For inductance and for resistance, it is the same law, okay, but for capacitance, it is the reverse way. So the equivalent capacitance will be again 1 by C equivalent will be equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by so and so forth, depending upon n number of such capacitances connected in series. And if they are connected in parallel, then this simple addition law works. Okay, so you also know this thing is C equivalent is equal to C1 plus C2 plus C3 and so on and so forth. There's nothing to, I mean, this is a very basic things you already have studied from 10th class. And for inductance again, that the resistance kind of law applies. So when they are in parallel, okay, so again 1 by L equivalent will be equal to 1 by L1 plus 1 by L2 plus 1 by L3 and so on and so forth if there are n number of such inductances connected in parallel. And in series again, the some simple addition law that works. So addition of all these inductances. So then there are different kind of energy sources. So then if voltage DC is there, then it is just the plus minus is so shown over here as voltage. If it is a time dependent time variant, then it will be VT. So this is the symbol, okay, for voltage. And for in correct case of current, okay, so you this kind of symbol whether downward or upward will be shown depending upon the direction, okay. But generally if it is a datum or this is a ground, okay, then this will flow from this. So this will be positive, this will be negative. So from positive it will flow in this direction and so on and so forth. Okay, so it is very simple now because you have only one or two components and this thing. But when circuit becomes very complicated, then we'll see that how it works. Okay, and for voltages also, if the two voltage sources they are connected in series, then the total voltage will be V1 plus V2. Okay, and current sources they cannot be, if they are connected in series then the same current will be flowing. So if they are connected in parallel, then there will be addition of current 1 and 2. Okay, so I1 plus I2, all these things. Okay, and then not only that, you can change from one current source into voltage source. Okay, and then how to change and all that technique also will be seen. So, so in network, how to now simplify network, something like this. For example, here, okay. So this is the circuit initially given. Okay. Now these voltage sources could be converted by earlier norms, whatever we have seen, into current sources. Okay, so all these sources now they have been converted into current sources. Okay, and when they are in parallel, you know that it is addition of this current. So only equivalent will be just one source. Similarly, this resistance and this resistance they are in parallel, so equivalent you can write down over here. Okay, similarly these again sources could be, these two sources could be now given as a one source by addition of this current over here, and these again are in parallel, so you can find out the equivalent and so on. So this was a very complicated circuit given, and you see that at the end this becomes a very simple circuit by using your all earlier knowledge of how to convert these sources into voltage source, and the reverse also is true. Okay, and many times what that we will be doing, that the voltage source will be converting into current source for analysis, to make the analysis simple. So the summary of all these things is given in this table. Okay, how all these can be converted into voltage into current, and all their symbols and their units and everything is given over here. So you know, you are very well versed about this thing, and sometimes some energy also if you need to calculate, their formulae are given over here. So is there any problem up to this point? यहाँ तक किसी को कोई प्रॉब्लम आई है, नहीं है, क्या है, आप बताएं, अकॉर्डिंगली विल गो फर्दर. हेलो हेलो, एनीबॉडी
No
देयर?
problem.
हाँ सर.
No
हाँ,
problem,
ये
sir.
तो आपने सारा किया हुआ है, बीएससी में भी किया हुआ है, और अभी तक आपने इस तरह का सारा किया हुआ है, ठीक है। और आपको ये अभी याद रखना पड़ेगा कि कैपेसिटेंस है, उसका उसमें के लूप एनालिसिस कर रहे हैं, और उसमें आपको करंट लिखना है, नहीं वोल्टेज लिखना है तो कौन सा फार्मूला लिखना है, और यदि करंट लिखना है नोड एनालिसिस में, करंट फ्लोइंग टूवर्ड्स और अवे फ्रॉम द नोड, तो कौन सा फार्मूला लिखना है, ठीक है। You will have to remember all this, because of just looking at that circuit, okay, and considering the current flowing in that particular loop or considering particular node, you will have to write down these equations. And not only that, when you have many different kind of as earlier also I have seen that there were two loops and all that, or many more.
Sir, you are muted.
Sir, sir, you are muted.
Okay, okay. So सो ऐसे ही रखे, ये दिख रहा है ना आपको, या प्रेजेंटेशन मोड में जाएं?
No, sir, it is visible.
सो इट्स ओके देन विल, बिकॉज वो म्यूट हो जाएगा तो बार बार वो प्रॉब्लम आएगी, ठीक है। So then there is a transformer, as I said, we use many times, okay, for stepping down or stepping up, or not only that, the transformers we use for the isolation of two circuits also, okay. So by because impedance of one circuit, if it is not matching with the other, for impedance matching also we use this kind of transformers. And in transformers, the thing is, there are two inductances, right? One coil and another coil. Not only that, there is a mutual inductance, because this because of the change in flux or change of current or voltage over here, there is a induced EMF in the other one, that you know, right? And that is how the voltage get transferred from one coil to the another coil in a changing kind of that signal, with time changing signal, right? Usually sinusoidal wave. And therefore we also have to consider, in addition to this, the mutual inductance. And while mutual inductance, what will be the sign of that mutual inductance, that we have to consider, okay. And therefore, if these, for example, two dots are on just one side, for example over here, the directions are over here is different, ये इस डायरेक्शन में फ्लो हो रहा है, ये इस डायरेक्शन में फ्लो हो रहा है, और ये जो डॉट्स है दिखाए गए हैं कि इसका जो इंडक्टेंस एट दैट टाइम इज गेटिंग ट्रांसफर्ड आउट फ्रॉम दिस टू दिस, ओके। एंड देयरफॉर बिकॉज द डायरेक्शन ऑफ करंट आल्सो यू हैव टू कंसीडर, डायरेक्शन ऑफ करंट इज अपोजिट ओवर हियर, and therefore though this is on the same side, okay, still the mutual inductance will be negative. आपको समझ में आई ये बात? यदि इनकी डायरेक्शन दो करंट की सेम होती, ये इस डायरेक्शन में है और ये भी इसी डायरेक्शन में होता करंट, तो फिर वो पॉजिटिव आता। तो ये चीजें भी आपको ध्यान में रखनी पड़ेगी सर्किट्स के, जब हम या नेटवर्क के इक्वेशंस लिखते हैं तब, ठीक है। ऑलराइट, सो अगेन देयर आर डिफरेंट कॉम्बिनेशंस की यहाँ और यहाँ डॉट है, उसका क्या मीनिंग होगा, नीचे ये दो डॉट्स है, इसका क्या मीनिंग होगा, ठीक है। So all these things are given very well in all these books, okay. And also the direction of current, whether it is going away or whether it is coming in from both the sides and all that. And from that direction, the ultimately the that sign of that mutual inductance will be decided. So not only these dots indicate whether this is over here and here, means that they will be having opposite kind of thing. And then after that you have to then consider the direction of current and decide the final sign of that inductance. So for example, here and here, okay, here and here, and then so there will be whether it will be plus and minus will be decided by both the direction of current and these symbols they give. Okay, if more than one, then they will be giving, for example, for from this to this interaction they will be giving this dot. But if there is another coil from this coil to this coil or this coil to, then they will be giving some triangle and square and all that, this kind of symbol. So you will have to consider all these things while considering the sign of this mutual inductance also. Okay, so this is all about this, and not only that, then whether it is a step up or step down, depending upon that, there is will be this coupling constant. So coupling constant is one usually for impedance matching transformers. This is less than one for your step down transformers, more than one for step up, and so depending upon number of turns and all that. So usually these are given. These things are usually given. So all the then when these inductance are connected in series, sometimes there also they can interact with each other. Okay, and there also such signs or such dots will be given, and depending upon that, you will have to consider this mutual inductance, whether it is interacting positively or negatively. Depending on that, plus sign or minus sign will come, and accordingly we will be deciding. So when we'll solve the problem, at that time all these things will come. So all these, whether the symbols are there and all that. Okay. For example, over here there are more than one coil interacting. So as I said, the signs are, they have been indicated by one is by dot, another by triangle, third one by this square kind of this thing, and accordingly these equations will be written, and their signs will be decided. Okay, and these are the again equivalent how to write that. I have done all these things. Just the repetition. I don't know why there is a repetition. See, this is about that, those symbols about whether the source is a voltage source, as I mentioned earlier. Okay, and whether it is controlled by another voltage. So there are something like that, voltage controlled voltage source. Okay, or these are again usually used while writing the equivalent circuits of those active components, transistor or FET and other components. So there you have voltage controlled voltage source, or current controlled voltage source, or voltage controlled current source, or current controlled current source. So these are the symbols. Just to give you the idea about what these symbols means, I have indicated this in this slide. Okay, so this is the kind of thing, again in short I have symbolized over here. Okay, so now you know that how voltage is considered in case of inductance and capacitance, and how current is considered. Okay, in these, so we'll see now how to write down equations. So preparation of equations, right? So basically in all our circuit analysis we'll be discussing how to write down equations for a circuit, and then usually you get generally first order simultaneous differential equations, or second order maybe simultaneous differential equations, or just one equation. And then you have to, using your previous knowledge and using the whether the initial conditions are given not given, you have to solve these things. So in a particular circuit, as I said, a reference node is considered, and that is called a datum, datum, that I have already explained. Okay, and the voltage, all voltages are measured with respect to this node or this point. Okay, and this is also a reference node. Then we, you know that we must use these Kirchhoff's laws, two Kirchhoff's laws, one is current law and another is voltage law. And then also we have to decide how many such equations we will have to write, and this is decided by this equation, number of nodes and number of branches. So each component, when it is connected, it is called a branch. So branch and number of this thing. So if there are b number of branches and n number of such kind of nodes, okay, then one node is already gone for this datum. So therefore we consider this n minus 1. So b minus n minus 1, that is b minus n plus 1. So these many equations you will have to write depending upon whether it is a node analysis or whether it is a loop analysis. Okay, and this all unknown voltages and currents provided using the your initial conditions. That is what we'll be doing. And for simplifying again, you know that all your laws of parallel resistances, parallel capacitances, and parallel inductances and series inductance, all this will be using throughout all this thing. Okay. So, so again, the network equations, there are some special kind of these networks, and they look like T in capital T in English. This thing. Some look like pi. Some look like what is called a bridge, and some look like box over here. So they have been given some special name also. So you will find that in while reading out this thing, you will find that T network or pi network or lattice network or something like this while solving this kind of equation. So basic is the whether it is a T network or whether it is a lattice kind of network or any kind of networks, there will be some special cases, but otherwise we have to keep in mind, considering the direction of current, considering voltage drop across each component, and considering again different kind of sources given, and from the sources how the current is flowing, we have to write down equations. And whether it is a capacitance and inductance and all that, considering all these things, we'll be writing different equations. Okay. So source transformation also, I don't know, again and again it is coming, that we have seen that when there is a voltage source and resistance is connected, okay, if you have to transform this into current source, then this resistance will come in parallel with the source. This is in series with this will come in parallel with this, and of course the this voltage will current into current, voltage will change into current, and then how much will be the quantity, and that you can find out from these equations. So not only all these things, but you know that when this current, this voltage is applied to a capacitance and it's charging, so whether it is lagging behind or leading and all these things, okay, that considerations also you will be considering later. So now we won't be going right now into all this detail, otherwise there will be a lot of confusion. So all these things we have done, again depending upon direction. This was all. So let us now take an example over here. Okay. So the earlier circuit, what we have seen. So you have some source over here, time dependent voltage over here. Okay. Applied to this circuit, LCR circuit. So you have one component as resistance, one is inductance, another is capacitance connected in series. Okay. And you will be finding out about the loop. So it means what? The voltage drop across each component, right? And current flowing through is here is I given, right? So the same current will be flowing through this loop or this circuit, okay? And therefore we can write down I into R, of course time varying, so it's time varying, so it is 2, T should be there, and this will be L into di by dt. You know that for voltage this law is there, right? This formula is there for voltage. Hello.
Yes, sir.
अभी शुरू में ही देखा ना हमने. And for
Yes, sir.
these And for this capacitance, voltage drop will be 1 by C to this 0 minus 2t I t dt, or tau I tau d tau rather. Okay. And so this again, convention direction, as I said earlier, you start from some point over here. तो given ये पॉजिटिव है तो ये पॉजिटिव होगा, तो ये पॉजिटिव टू नेगेटिव, ठीक है, और फिर ये पॉजिटिव टू नेगेटिव एंड पॉजिटिव टू नेगेटिव. So all these are plus signs. Plus when it comes to here, it is from negative to positive, and therefore negative sign. And using this KVL voltage law, we can write down the voltages, sum of all voltages in a loop, okay, equal to 0. And therefore now you see that this equation becomes I into R plus L into di by dt plus 1 by C integration I dt is equal to Vt. यहां तक ठीक है? आपको समझ में आया?
Yes, sir.
यस सर।
अब ये इंटीग्रेशन है, यहाँ पर इसको एलिमिनेट करने के लिए हमको एक बार और डिफरेंशिएट करना पड़ेगा, ठीक है, क्योंकि इंटीग्रेशन डिफरेंशिएशन विल गो देन, राइट.
Yes, sir.
डिफरेंशिएशन ऑफ इंटीग्रेशन 1 हो जाएगा ना, वो नहीं. अरे इंटीग्रेशन डिफरेंशिएशन एक दूसरे के अपोजिट है कि नहीं?
Yes, sir.
इंटीग्रेशन एरिया लेते हैं, उसमें टेंजेंट लेते हैं. So therefore you have to differentiate again one more times, and therefore if you differentiate in this circuit, so it becomes L d2 d2i by dt square plus R di by dt plus 1 by C into I is equal to dVt by dt, and therefore you get the second differential equation. समझ में आया?
यस
Yes,
सर.
sir.
यस सर।
Yes, sir.
So in most of these things you will be having different loops, but now there is only one loop. So you got only one differential equation. But if there are say 3-4 loops, circuit complicated हो सकता है कि नहीं इससे?
Yes, sir.
Then there will be more simultaneous differential equations, and then you will have to solve. So solving such kind of differential equations sometimes is not easy, but we will have to do it. So that is what all we will be doing in all our next few classes. We will now try to know how to solve, try to discuss how to solve these different differential equations, और उसकी क्या क्या मेथड्स है वो सॉल्व करें, वो कोशिश करेंगे जानने की और डिस्कस करने की. फिर कुछ प्रॉब्लम लेंगे, उनसे कुछ सॉल्व करेंगे. सो एक्चुअल हम जो नेटवर्क का जो सॉल्व करेंगे वो डिफरेंशियल इक्वेशन सॉल्व करेंगे, और उसके इनिशियल कंडीशंस क्या होगी क्या नहीं, एक तो दी है तो ठीक है, नहीं है तो कैसे फाइंड आउट करना है वो भी देखेंगे, ठीक है. फॉर एग्जाम्पल हियर नाउ यू कैन सी देयर आर 2 लूप्स, यू कैन सी, ओके, एंड वन वोल्टेज सोर्स इज गिवन. करंट सोर्स होता तो नोड एनालिसिस करते हैं हम. अब इसमें जो है कितने नंबर ऑफ इक्वेशंस लिखने चाहिए, तो हमने फार्मूला तो दिया था आपको b माइनस n प्लस 1. तो आप सारे काउंट कर लें कितने है कि नहीं है. 1 2 3 4 5, तो 5 ब्रांचेस हैं. नोड्स कितने हैं? 1 2 3 4 नोड्स हैं. सो देयरफॉर कितने इक्वेशंस लिखे जाएंगे? 5 माइनस 4 प्लस 1 इज इक्वल टू 2. एंड वैसे भी आपको दिख रहा है इसमें 2 लूप्स है, तो 2 लूप्स के लिए डिफरेंट इक्वेशंस, 2 डिफरेंट इक्वेशंस आएंगे, ठीक है. अब कैसे लिखेंगे ये तो मैंने कॉम्पैक्ट फॉर्म में थोड़ा उसको किया, पर इनिशियली स्टार्ट करेंगे तो जैसा पहले एक लूप के लिए किया वैसे ही करेंगे, लेकिन बट now you will see that through this capacitance this I1 will also flow and I2 will also flow, right? And therefore while writing down this equation for this loop, okay, you will be writing down R1 I1, if you the current flowing through this is I1, 1 by C, okay, into integration I1 tau d tau, ये इसके लिए आएगा, इस करंट के लिए. लेकिन जब ये करंट और ये करंट अपोजिट डायरेक्शन में आए, यू कैन सी द डायरेक्शन, दिस इज फ्लोइंग इन दिस डायरेक्शन, व्हाइल When it comes over here, this will be flowing in this upward direction. So this is in downward direction, this is upward direction. And so therefore, if you are considering this as positive, then this will be negative. And therefore, this will be minus 1 by C integration of I to tau d tau, or you can write now this minus sign or common lekar ke 1 by C integration I1 minus I2 dt. In fact, integration में tau लिखते हैं, different is if it is symbol, but doesn't matter. And equal to now minus, ये आता है तो minus negative to positive जा रहा है ये, तो इसीलिए minus VT equal to 0. तो ये पूरे लूप के लिए सम ऑफ ऑल दिस वोल्टेजेस इज इक्वल टू 0. फिर ये माइनस साइन इधर लेंगे तो ये VT इज इक्वल टू दिस थिंग, दिस इक्वेशन यू विल गेट. ओके, नाउ अगेन यू विल,
ये मेश एनालिसिस है ना?
मेश
एनालिसिस है ना?
हेलो, दिस इज लूप एनालिसिस और मेश एनालिसिस, राइट? इट्स कॉल्ड लूप एनालिसिस और मेश एनालिसिस. लूप एनालिसिस भी कहते हैं उसको, या मेश एनालिसिस भी कहते हैं. And you can rearrange this again. Again, you will have to differentiate this one more time. No, हाँ, इसको तो इसमें only one derivative, क्या कहते हैं, first order derivative will come. So R1 di 1 by dt plus 1 by C minus I2 minus I1 is equal to dVt by dt. ठीक है, ये वैल्यूज दी है तो बाद में हम वैल्यूज डाल देते हैं उनमें, आर की, सी की, और फिर वो सिंपल डिफरेंशियल इक्वेशन बन जाता है, उसको सॉल्व करते हैं. ये इसके लिए जब ये करेंगे अब तो एल और सी दोनों आएंगे इसमें आर और सी था, तो इसमें एक इंटीग्रेशन भी आएगा और एक डिफरेंशिएशन भी आएगा. वो तो लिखा ही था हमने पहले, इससे पहले वाले में. ठीक है, और दो करंट्स आएंगे जब कैपेसिटेंस के, तो देयरफॉर द इक्वेशन विल गेट मॉडिफाइड टू दिस, एंड दिस होल सम इज इक्वल टू 0. तो इसमें VT नहीं आएगा, इधर इक्वल टू 0 आएगा. ठीक है, तो अब हम आगे यही देखेंगे कि इससे इस तरह के बहुत सारे इक्वेशंस कैसे लिखे जाते हैं. नोड एनालिसिस में जब करंट सोर्स होता है, देन यू कंसीडर द नोड ओवर हियर, एंड वेदर यू कंसीडर वेदर इट इज गोइंग अवे or coming towards, and accordingly you decide the sign. So at this particular point, so ऐसे different points consider करके उसके उतने equations आएंगे. Again you can find out how many equations should be written over here. So you will find out that again 2 equations, कितने branches है वो count करें, कितने nodes है वो count करें, और apply that formula and you will come to know. So for all such kind of different circuits or different networks, what are called, we will be writing different kind of such equation. तो हमने अभी तक ये सीखा है कि इक्वेशंस हम कैसे लिखेंगे और वो सेकंड ऑर्डर या फर्स्ट ऑर्डर डिफरेंशियल कैसे आएंगे. अब हम देखेंगे कि सर्किट्स में जब ये इस तरह के बहुत कॉम्प्लिकेटेड होंगे तो उस केस में हम क्या करेंगे, उनको क्या सिंप्लीफाई करेंगे, या कुछ इस तरह का कोई नया ग्राफ थ्योरी या कुछ और थ्योरी अप्लाई करके वो हम उनको ये करने की कोशिश करेंगे. सो टुडे आई थिंक वी शुड स्टॉप ओवर हियर, टाइम इज ऑलरेडी ओवर, एंड माय
Yes, sir.
tomorrow's class then I will start graph theory, how that graph theory will be applying to your such kind of networks to simplify this network, or to write these equations in a matrix form, and then how it becomes easier to solve such kind of, because there will be such number of simultaneous equations, and solving the simultaneous equation by this usual method is not that easy, and we'll find out the way for solving such kind of equations. So thank you very much for listening patiently today's my lecture, and we'll continue for tomorrow and day after tomorrow. So we are going to get around 9 to 10 lectures, and we'll see how we can manage the whole course, okay, within this much time provided to us.